by the way in which the order is returned or it is sorted. By default, it is sorted in ascending order, but you can change that by specifying your preference inside a select statement. So let's look at the syntax. So the syntax is this. This is how you would include an order by clause inside your select statement in order to sort the data that is returned from the query in a particular order. So you start with the select statement. So you're selecting, say, column 1, column 2 from the table. This is the table you're selecting it from. And then you specify the order by. The order by is usually comes after is the last thing you add in a statement. So you usually specify the order by clause after the select statement, the from, and then you specify the order by. And when you order by, you can specify the column you want to order by. So you can order by a specific column. Here in this syntax here, we're saying we're ordering the first column in ascending order, and we're ordering the second column in descending order. So that's how you specify the syntax when you want to sort data returned from a select statement. If when you write a select statement and you don't specify an order by default, the data that is returned from a select statement is sorted in ascending order. So if you don't specify an order by, it would automatically sort the data in ascending order. In other words, it will order the data in the order in which the data was inserted into the table. For example, if Joe Bloggs was inserted into the table before Anna Smith, then when the query is returned, it will return Joe Bloggs before Anna Smith, unless you specify an order by to sort the data. So when you are ordering data or sorting data, you can sort it by multiple columns. If you're sorting by multiple columns, you need to separate each of the column by a comma, just as you would here when you are selecting columns to retrieve data from. So if you are ordering by several columns, make sure you separate each of the column by a comma. So the key purpose of using the order by clause is to help you sort or filter the rows returned from a select statement. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to divide rows into groups by using the group by clause. The group by clause is used to divide the rows returned from a select statement into groups. Using the group by clause, you can apply aggregate functions to the columns. For example, you can apply aggregate functions like the sum to calculate the sum of the items, or you can add the count aggregate function to the columns. With the count, it enables you to get the number of items in a group. So let's look at the syntax for implementing a group by clause. So it's always implemented with a select statement. So you got the select, then you follow by the column name, then the aggregate function, and inside the parentheses for the aggregate function, you specify the column you are applying the aggregate function to. Then you select the table name from the from field, and then you apply a group by column. You then group the column by the column name after the aggregate function has been applied. What are aggregate functions? Aggregate functions are basically used to perform calculations on data. Aggregate function mostly returns a single value based on calculations from the columns. So the data returned by an aggregate function is a single value, but calculated from the values in a column. Let's have a quick look at a brief table showing some aggregate functions. So this is a brief table here of some common aggregate functions and their description. So we've got the AVG or average. It's used to return average value. The count returns the number of rows. The max returns the largest value. The mean returns the smallest value. The sum returns the sum. The first and the last returns the first and the last values. So let me show you an illustration of how a group by clause works. So I'm going to use this DVD rental database, and this database has got 15 tables, and I'm going to use one of them to illustrate. The table I'm interested in here is the payment table. So let's take a look at the columns. These are the columns in the table. So you've got the payment ID, customer ID, staff ID, rental ID, amount, and payment date. You don't always have to use an aggregate function with a group by. You can use the group by clause without applying an aggregate function. So I'm going to show you an example where you don't have to use an aggregate function. So let me open up the query tool, and I'm going to pick a few columns from this table here. So I'll start with a select statement. Type in the select keyword, followed by, I'm going to pick the customer ID. Comma, and then I'm going to, I'm just only going to pick one column from now, and then type in the from field. The from will be payment. Then I'm going to apply a group by. I'm going to group it by the customer ID. Underscore ID. So what this query will do, it will get data from the payment table and group the result by the customer ID. So let's run the query so we can see. Ooh, I've got an error there. The reason being, you can see these dotted lines. It means that it doesn't recognize that column. I've got it wrong. It should be customer underscore ID. So let me rectify that. All right, and then semicolon. Now it should work. Ooh, still doesn't work. Okay. Okay, the query has finally worked. For some reason, I got the underscore wrong. Anyway, so this is it. This query here, as I've used it to get the data from the payment table and grouped the result by the customer ID. So this is the kind of thing that an aggregate function will do as well, because when an aggregate function is applied, it will return a single value, as you've seen here, but you don't always have to use the aggregate function with a group by clause, as I've illustrated in this example. I'm going to amend this query and add an aggregate function. The group by clause is always useful when it is used in conjunction with an aggregate function. For example, to get how much a customer has been paid, you can use the group by clause to divide the payment table into groups. For each group, you can calculate the total amount of money by using the sum aggregate function. So let's do that. I'm just going to amend this query. So I'll leave the column as a customer ID, and after the column, I'm going to apply an aggregate function called sum, and I'm going to do the sum on the amount. This table has an amount column, which is this here. This amount column is what I'm applying the aggregate function to. So let me execute this query. Ooh, made some error there. Amount. Okay, it thinks I've got the amount wrong. Yeah, what I should have done is put a comma after the first column here to indicate that I'm adding another column. So let's try again. Okay, that's much better. As you can see, the group by clause sorts the result set by customer ID and also adds up the amount that belongs to the same customer. So whenever the customer ID changes, it adds up the row to the returned result set. You can also use an order by with a group by clause. So what I can do, I can add an order by just at the bottom here. I'll get rid of that semicolon, come here and type in order by, and I'm going to order by the aggregate function and then the amount, and I'm going to do that in descending order. Okay, so watch out for this result output. It should change. I'm going to click on that. As you can see, the format has changed. So by adding the order by clause with the group by clause, it sorts the groups as well. You can also use the group by with a count function. So I'm going to modify this query slightly to use the count function. This payment table here has a staff ID. So what I'm going to do, I'm going to change this customer ID to staff ID. And I'm going to apply a count function. And the column I'm going to apply the aggregate function to is the payment ID. So I'm going to change that and add a payment ID. And I'm going to group the result by the staff ID. And I'll get rid of the order by and put a semicolon to end the statement. So to count the number of transactions each staff has been processing, you group the payments table based on the staff ID, and then you use the count function to get the number of transactions as this query indicates. All right, so let me run that and then we can see the output. So that's it. The group by clause sorts the result set by the staff ID. So it keeps a running total of the rows, and whenever the staff ID changes, it adds the rows to the returned result set. So that's it for this lecture on using the group by clause. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the having clause to eliminate groups of rows that do not satisfy a specified condition. The group by clause is usually used in conjunction with the group by clause. It is used to filter group rows that do not satisfy a specified condition. Let's have a look at the syntax to see how you would implement an having clause. So basically this is how you would implement it, usually after the group by. So you start with the select keyword followed by the column name and then the aggregate function you want to use, and inside the parentheses the aggregate function column, the column you want to apply the aggregate function to. And then you specify the table name in the from field, and then you apply the group by what column you're grouping it by, and then you apply the having condition. The having condition always comes after the group by. The having clause sets the condition for the group rows created by the group by clause. Although you can use the having clause with the group by clause in conjunction, in Postgres you can use the having clause without the group by clause. So let me show you an illustration of how the having clause is used. Before I do that, I've got a query here I just want to run. Basically this query is just showing the group by clause. So I've got the select keyword. I'm using the customer ID from this payment table here, and I've got the sum aggregate function that I'm applying to this column called amount from the payment table, and I'm grouping it by the customer ID. So let me run that so you can see what it looks like before I add an having clause. So this is what the query looks like at the moment. I'm going to add the having clause in order to implement or set some conditions. So after the ID here, I'm going to take off the semicolon and then implement the having clause. Inside the having clause is where I'm going to specify some conditions. So I'm saying having sum, and I'm going to use the amount column, so this is a condition I've set. So after the group by has been applied using the customer ID, I've set extra condition using the having clause with the sum aggregate function. So it's going to apply to any amount greater than 200. So we should have a much reduced output. So let me run that and you can see the result. You can see we've only, so this, by using the having clause, only conditions that match this criteria have been displayed. You can see this amount here, these two amounts match this, they're greater than 200. So this is an example of how you can use the having clause. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture you will learn how to truncate and drop a table. Truncate basically means you remove all the data from the table. You strip the table of its data. And drop basically means delete. When you drop a table, you are deleting it or removing it from the database. So truncate removes all the data from a table, while a drop will delete the table from the database. So the syntax you will write to truncate a table will be this. You start with the word truncate, followed by the word table, and then the name of the table. If you were to drop a table, you start with the word drop, followed by the word table, and then the table name. Let's see how this works. I've logged into my pg4admin tool, and I am going to delete and I'm going to drop and truncate a table from the fruits database, this database here called fruits. And the table I am going to truncate and drop is this table here called person. So I'm going to right click and go to query tool, and that would take me directly to the table. And what I'll start with the word truncate. I'll type in T-R-U-N, truncate, followed by the word table, followed by the name of the table. Name of the table is called person. All right, so before I do that, I want to do a quick select statement so that we can see what data is in there. All right, so I'm just going to highlight this and execute. So we've got two records or two rows of data in this table here. All right, so I'm going to truncate. When I truncate, it should get rid of the data. So I'm highlighting and I execute. It says it's done that. So let me run the select statement again. And the table should be stripped of data. So it has successfully stripped that table of its data. So that's basically what a truncate does. All right, now let's try and drop this table. We want to remove the table from the database. So to remove the table, I'm just going to replace the word truncate with drop. Now, if I execute this, it should delete the table. All right, so if I try and run this query again, if I refresh the table list here, it should change from 3 to 2. It has changed to 2. If I try and run this query again, it will tell me that table does not exist. Error, person does not exist. So that's how you truncate and drop a table. Thanks for watching. Bye for now. Hello and welcome to this section. I'll be introducing you to the PostgreSQL stored procedures. What are stored procedures? Stored procedures are basically a set of SQL statements that can be given a name and stored on the relational database management system as a group, and can be reused whenever it is required. They can also be shared by multiple applications or programs. PostgreSQL basically uses stored procedures for developing functions. So they allow you to extend the functionality of the database with user-defined functions. So user-defined functions are also represented as stored procedures. You can use stored procedures to define various types of functions. For example, you can use it to create triggers or custom aggregate functions. Let's take a look at the advantages of using stored procedures in Postgres. The first is basically reduced network traffic. So basically, a stored procedure reduces the number of round trips between application and database servers. So basically, all the SQL statements are wrapped inside functions stored in the PostgreSQL database server. So the application only has to issue a function call to get the result back, instead of sending multiple SQL statements and waiting for the result between each call. It wraps everything and makes the round trips between the application and the database server. It reduces that and therefore reduces the network traffic. It also increases the application performance because user-defined functions basically are pre-compiled and already stored in the database server, so it makes it a lot easier for the application to reference it. Also, stored procedures are reusable, so you can reuse it in many applications or program. Once you've developed a function, you can reuse it in any application. Once it's created, that's it, you can reuse it anytime. So let's also take a look at some disadvantages. So some disadvantages of using stored procedures include slow software development. So it is slow in software development. This is because it requires specialized skills that many developers do not possess. So there's probably not enough developers with skills to support that in software development. So as a result, that can impact on the software development time. It also makes it difficult to manage versions and also hard to debug. Makes it hard to debug and manage the versions. Another disadvantage is that it may not be portable to other database management systems like MySQL or Microsoft SQL Server and so on. So these are some of the key disadvantages of using stored procedures in PostgreSQL. So in this lecture, I introduced you to PostgreSQL stored procedures, which in a way are basically a bunch or set of SQL statements that are stored in your database. They are also user-defined functions, so they are functions that are defined by the user, and you can use them to create triggers, custom aggregate functions, and other stuff. So the key thing to note is that they are basically user-defined functions that are stored in the database. Many thanks for watching, and bye for now. Hello and welcome to the introduction to this section, which is the Postgres CRUD operations. CRUD basically is an acronym for create, read, update, and delete. A lot of the times, the operations you will perform on a Postgres database will be to create, to read, to update, and to delete. You also obviously need to add records, and you do that with the insert command as well. But CRUD stands for create, read, update, and delete. So we'll be performing these operations in this section. Thanks for watching. Hello and welcome to this lecture. In this lecture, you'll learn how to create a database using the pg4 admin tool. To access the admin tool, you need to go to all programs if you're on a Windows and locate the Postgres folder. If you expand that, the pgAdmin 4 tool is located inside that folder. So click to launch the tool. Give it a few minutes to launch. When the admin tool loads up, just click to expand the servers and click on the Postgres server. Once you click on that, it will give you an option to log in. So if you can just enter the password that you entered during the installation of the Postgres server. Click OK. And it should give you access. It tells you server connected on the bottom right. So now to create a database, we just right click on this databases folder here and click on create and then database. It should give you a dialog box to enter some details. You need to enter the database name. I'm going to call mine fruits. And you can put a comment if you want. I'm just going to say database of fruits. And that's basically it. If you click save, it should create the database. Give it a few minutes. So the database has been created. That's the database here. When you create a database, it jumps to the top. So that's the database we've just created. So click on the plus sign to expand it so you can see more about the database. So these are all the objects that come with the database. This is a schema. If I expand that, it creates it under the public schema, and it also creates other stuff. So these are other objects that are created when you create a new database. So we can check on the properties by clicking on this property icon there to see what the properties are. And this is basically the properties of the database. So when you create a database, by default, there's certain things you enter, others can be completed for you. Like these here grayed out, there's the security option here. So none of that was completed. The definition was inserted for you. This is the encoding. By default, it gives you this table space. Collation indicates the language you're using. So I'm in the UK, so it's put that there. Template, it says no, I'm not using any template. Allow connections, yes. You can also decide not to allow a connection if you create a database and you just want to use it for testing purposes and you don't want any connection while you are doing some tests. Other things you can check, click on the SQL to see this is the SQL that was actually generated when you create a database. So if I was to create a database using SQL or SQL, this is how I would create it. From the information I provided, it has generated a SQL for the database. So this is the SQL used to create the database. Click on statistics. There shouldn't be that much. So these are various statistics relating to the database. Dependencies, there shouldn't be. Dependents, there's no dependents. So you can also access the property page by right clicking on the database itself and going properties. Once you're in the properties, you can also click on the definition. This was the only information we completed during the creation of the database. The definition part was actually inserted for us by this tool. So all this here, we didn't do it. The tool inserted it for us automatically. And security, if at some point you want to implement security on the database, this is where you will implement the security. So you have to be a guarantor to add privileges, and then this is where you grant the users. Parameters, if you've got any parameters, this is where you add it. Default privileges, if there's any, this is where it will be. And the SQL here tells you nothing has changed from the SQL that was used to generate, or the SQL that was generated when the database was created. So that's basically how you create a database using the pgAdmin 4 tool. Many thanks and bye for now. Hello and welcome to this lecture. In this lecture, you will learn how to create a table using pg4admin. Open up your pgAdmin 4 tool. I've already opened mine and I'm already logged into the server. So to create a table, there must be a database already in presence. So you create a table inside a database. So the database I'm going to create a table on is this database called fruits. We created this database earlier. So I'm just going to expand this database and look for the schema. This is a schema. Inside the schema, which is called public, there are tables. although there's no tables at the moment, but this is where you create tables from. So to create a table, you right click on tables, which is under this fruits database, and click on create and then table. And it should give you an option to enter the table name. So I'm going to call my table oranges. And it tells you the owner is Postgres, the schema is public. You can select a table space if you want. Once you've done, just click save and it should create the table name. So you can see here, that's the table oranges. We've now created a table. So we can go back to the table, right click and go properties, and we can add more bits to the table. We can add columns. So to add columns, we click on that. And before we do that, let me click on the general tab. You can see it's created it in the default pd underscore default table space. So let's go to columns and let's start adding the tables, the columns. It gives you option to, you can inherit from tables. If you've got other tables, you can inherit columns from tables. Gives you that option, but I'm not going to do that. I'm going to create new columns. So click on this plus sign here to create a column. So with tables, they store data in columns and rows. So I'm going to call this category ID, and I'm going to select the data type, which it has to be an integer because it's going to be a number. So I'll select integer, leave this to blank, and I'll select, do I want it to accept null value? No, I want there to be a value, so I say yes. Do I want to make it a primary key? Yes, I want it to be the primary key. So this column here, all the records in this column will be unique. So that is the first column. So I click to save it, and I can add more columns. I go back, go into properties, I wait for it to load, and then I go to columns again, and I click on the plus sign, give me another row. So this time I'm going to add the name, and I'm going to make the character varying character. So I'll type in character varying, so it'll be a varying character. You can give it a length. I'm going to give it 25 for the name. I don't expect there will be any fruit that will have more than 25 characters of name. Again, I want there to be a name. I don't want that value to be empty, so I say yes. I want it to be a null value. I don't want any null value. Null means there is no, you don't know. So but by making this yes is forcing you to enter a name for the category. So I click save. I'm going to add one more. I go right click again, I go properties, wait for it to load, and I'm go columns, and click on the plus sign. I'm going to make this color. So I want to find out the color of the fruits. Again, I'll make this varying, character varying. I make it 25 as well. I'll leave this. So this can be empty if you're not sure what color the fruit is. So I don't want to enforce that. So I'll leave that option open. So if people are not sure what color it is, I want that left blank or null. I'll click save. So we've now created a table with 3 columns. If I expand this, you can see the columns of the table. So these are the columns. It tells you here 3 column. There are other things you can apply to the table. If I go on the properties, for example, you can give it you can apply constraints. You notice because I've added a primary key to one of the table, it's made that a constraint. Constraint basically, in a way, is kind of like a check. It forces you. It means you can't progress unless you enter something in that field. Okay. So there are other options here: advanced parameters, security. You can add security to a table. So you can give access or restrict access. If you want to do that, this is the area you will be doing that. And the SQL basically tells you nothing has changed since the table was created. So if you want to see the SQL that was used to create the table, all you need to do, let me cancel out of this. I click save. So if you want to see the SQL or the SQL, you right click on the name of the table, and where it's got scripts, just click on create, and that will generate a script with the create command. So there you go. So this is a script that you would use if you were to create it without, that is not with the table, not from within the admin tool. So this basically is the SQL or the script used to, this script was generated when you created the table. So if I wasn't going to use the admin tool, I wanted to use SQL or SQL, this would be the SQL I would use to create the table. So that's it for this lecture on creating a table using the PG4 admin tool. Many thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, you'll learn how to use the Postgres create table statement to create a table in a database. Let's take a look at a typical syntax to create a table. So this is what a typical syntax looks like to create a table. You begin with the create table command, followed by the name of the table, and then in between the parentheses you specify the names of the columns the table will contain. A table can have as many columns as you wish to specify. So once you specify the name of the table, you then begin to define or specify the names of the column. So you start with a column name, followed by the data type, if it's going to be an integer, which is a number, or a text. And there are different types of textual data type. So you need to insert that. And then if you want a constraint on the column, you also need to add that. A constraint basically is a condition that you apply to a column. For example, you can add to a column that you don't want that column to be empty. There must be a value. That is a kind of constraint. So let's go over to our PG4 admin editor and create a table. I have already logged into the PG4 admin tool. So I'm just going to expand the list of databases. When you create a table, you need to create it in the correct database and schema. So I've got 3 databases listed here. The database I want to create a table on is this one here called fruits. So I'm going to expand that and then expand the schema, and you should see one for tables. There's only one table there. So what I need to do, I need to access the query editor. So I right click and go query tool. You can also access the query tool from the tools option and click on query tool. So I have now got my query tool open. So this is where I'm going to define my table. As you can see here in the editor, it says fruits on Postgres. So it knows that I am in the fruits database, which is this database here. So that's where I'm creating the table in. So I'll start with the create table command. Followed by the name I want to call the table. I'll call it berries, and then I have to enclose parentheses, and then I put my mouse in between the parentheses and expand it. So in between this parentheses is where I'll define the columns for the table. So the first column I'm going to define is going to be the ID. So I'm going to type in berry underscore ID. I'm going to make that the primary key. A primary key basically is a column or a group of columns that is used to identify a row that is unique in a table. If you are adding more columns, you put a comma at the end of the first column, and then you tab to the next line and then add another column. So I'm going to type in berry underscore name. Again, I need to specify the data type this time. It's going to be a voucher data type that will accept, that can allow 255 characters, and I'm going to set a constraint. A constraint basically means that you are applying some kind of restriction or a rule to that column. What not means that there must be a value in this column. That is, it cannot be empty. For illustration purposes, I'm just going to leave it with 2 columns. But you get the idea. You can add as many columns as you wish to in a table, but for this table I'm just going to make it really simple and just leave it at 2 columns. So I want it to be a 2-column table for now. Once you're done, you need to put a semicolon at the end to indicate that you are done with creating the table. You can always add columns later when the table has been created. Once you're done, you can now execute the query to create the table by clicking on this here. So once you've executed, it tells you that query returned successful. So successfully created the table. It tells you the command you used. Notice that I've added a data type. You must always have a data type when you're creating a column, so that the column knows what type of data to expect. So here, after the name of the column, you need to add the data type. This is an ID column, which is going to be an integer, which is a number. So this int means integer. So that's the data type for this column. So basically, this is a simple format that you can use to create a table. You can make it as simple as this one or as complex, whereby you can also add a constraint to several columns within a table, or you can also add constraint to the table itself. So let's quickly query this table that we've just created to see if we can communicate with it. So I'm going to quickly write a select statement. I'll do select star from berries. It's very important to always just check what you've done, just to make sure everything checks out. Okay, So I'm highlighting that and I click. As you can see, it's successful. It tells you we've got 2 columns in this table, tells you the data type, but there is no data inside the table. So we've got the table structure all in place, waiting for data input. Thank you for watching, and I hope the lecture has been useful. So this is how you create a table using Postgres create table command. Thanks for watching, and bye for now. Hello and welcome to this lecture. In this lecture, I'll be introducing you to Postgres select statement. One of the most common tasks you will perform when working with Postgres is the task of querying data from tables, and you do that by using a select statement. So the select statement is basically used to query data from a table. The select statement can be very basic, or you can make it complex by combining it with several clauses. So you can use it in combination with other clauses to make the select statement more complex and powerful. There are several ways you can build a select statement, but let's have a look at the basic syntax you can use. A syntax basically refers to how something is written. So for a very basic syntax or a very basic select statement, you can specify the column. For example, a table stores data in columns and rows, just like in an Excel spreadsheet. If you wanted to query data from a table, you have an option. Rather than query all the data, you may want specific data to query. So you can do that by selecting the columns individually and specifying the table where the data is coming from. And the way you will write that statement is this. You do a select, which is a select keyword. Select indicates you are trying to retrieve data. Select doesn't cause any damage to the database. There's no risk because all you're trying to do is read data. So you start with the keyword select, followed by the columns you want to retrieve data from. Say you have a table that has maybe 20 columns and you only want to retrieve data for 2 columns. Rather than retrieve everything and then sift through what you want, you can specify the actual columns you want to retrieve data from. This also helps save network traffic. Rather than pulling all the data from a table, you only pull down the specific data you need. So you assume you want to retrieve data from column 1 and column 2 from a table that has 20 columns. So you just specify column 1 and then you separate each column by a comma. Okay, so I want to retrieve data from column 1, comma, and then column 2. You don't need to put a comma at the last column because there's only 2. If you were to add another column, then yes, you put a column after the 2, but not with the last column. And then you need the from. The from is very important because the query needs to know where it's pulling that data from. So the from is used to specify the name of the table. The other way you can write a select statement is if you wanted to retrieve all the data from a table. So you want all the columns and all the rows. You don't want to be specific. You just want to get everything out of that table. The way you specify that statement is this. You do a select keyword followed by the asterisk symbol. That asterisk symbols indicates that you want to retrieve all the data from all the columns and all the rows. You also have to specify a from field, which indicates the name of the table the data is coming from. So these are the two basic ways you can write a select statement. These are just basic. You can obviously make it more complex by adding other clauses to it. But at the very basic, this is what a select statement looks like. This is how you would write it. You can also obviously make the select statement more complex by adding things, other keywords or clauses to make the query more complex. But in a very basic select statement, this is how you would specify it. So that is it for this lecture. Thanks for watching. Bye for now. Hello and welcome to this lecture. In this lecture, you will learn to use subquery to build complex SQL queries. A subquery basically is a query nested inside another query, and this can be with a select statement, an update statement, and also an insert statement. To construct a subquery, the second query is placed inside brackets, and also you have the where clause used as an expression in the subquery. So a subquery basically is an SQL statement that has another SQL statement embedded in the where or in the having clause. So let's look at a typical syntax. This is what a syntax will look like. So this portion here where you've got the brackets, that's this bracket here and this one here in between, this is known as the inner query. So this here is the embedded query. It is known as the inner query, while this portion here, this part of the query here, is known as the outer query. So I've changed the color to make it more pronounced. So the part in yellow here is known as the outer query, while the query in green, which has brackets around it, is known as the inner query. All right, let's start with a very simple example. So I've got a simple query here where I'm selecting the rental rate from this film. This is the film table, and this is the column I'm selecting, and I'm applying a AVG, which is an aggregate function, to this column here called rental rate, which is this column there. So suppose we want to find the films whose rental rate is higher than the average rental rate. So we can do this in two steps. First, we find the average rental rate by using the select statement and the average function, which I've specified here. The second step is to use the result from the first query in the second select statement to find the films that we want. So let's execute this so we can see the result. All right, so let me just expand that a bit. So this is the result from this query. So approximately is 2.98. So which means the average rental rate is 2.98. Now we can get the films whose rental rate is higher than the average rental rate. So I've implemented this query here. This query you can see to find the films whose rental rate is higher than the average rental rate. You can see here I've used the greater than sign. So I've said select the film ID, title, and rental rate from this film table where the rental rate is higher than 2.98. 2.98 was the average we found. So let me run this so we can see what it outputs. So this is the output from this query. You can see these are the rental rates. The way the code is implemented at the moment is not that elegant. So what we can do, we can make it elegant in 2 steps, and we'll do that by implementing a subquery. So what we want to do, we